number 7 in objective 3 says find an exponential equation of the form y equals ce to the kt that passes through these 2 points. Again, remember this is just another version of the PERT formula that you're familiar with. Okay. These problems came up in our assignment, and what we want to do is plug them both into this equation to create a system. So we'd have 3/2 equals c times e to the k times 2. And then when we plug this one in, we would have 5 equals c times e to the k times 4. Okay. This is one where we don't have an initial value, so we've got 2 variables and 2 equations. Lots of ways to solve the system. I would recommend dividing the one with the higher power by the one with the smaller power. So I'm going to divide 5 equals c times e to the 4k by 3/2 or 1.5 equals c times e to the 2k. The advantage to that is the c's drop out, cancel each other. And let's see, 5 divided by 1.5, we could call it that, or we could call it 10/3 equals e to the 2k. When you divide powers of the same base, you subtract the exponents. Okay. When we want to solve for an exponent and we've got a base e, we want to take the natural log of each side. The advantage of that is this power then can jump down in front. The natural log of e is just 1, so we don't have to worry about that, but we would want to divide by 2. Make sure when you type this into your calculator that you're closing that parenthesis and then dividing by 2, and that should give us the value for k. K should end up to be about 0.6 or 0.602. Now we've got k, but we need to find c, so we can plug it back into either one of our equations to find that. Okay. I'll plug it into this one. Remember that this is just a big exponent, so e to that value is just a number. Okay, so I would divide by both sides by e to that exponent and end up getting about 0.45 for c. Okay. So the final answer, y equals 0.45 e to the 0.6 or 0.602 t. All right. Number 8, another exponential application. The sale S in thousands of units of a new product after it has been on the market for T years is given by this equation. Find S as a function of T, which it is already, again with an extra variable, if 4,000 units have been sold after 1 year. So T equals 1 and S equals 4,000. Right. But S is in thousands of units, so we really just want to call S 4. All right. And so if we plug that into this equation, we'd have 4 equals 25 times 1 minus e to the k times 1 power. All right. Divide both sides by 25. And 0.16 equals 1 minus e to the k. Subtract 1 from both sides. You get negative 0.84 equals negative e to the k. We'll go ahead and take the opposite of both sides. So we'd have 0.84 equals e to the k. Again, there we've got a base e and an exponent, so we'll take the natural log of both sides. This k can jump down in front. Natural log of e is just 1. So k is the natural log of 0.84, or about negative 0.174. So the final answer for A is S equals 25 times 1 minus E to the negative 0.174 T power. Then for B, it says how many units will have been sold after 5 years. So 5 is the time. We're going to plug that in there and find S. So S equals 25 times 1 minus E to the negative 0.174 times 5. Just type that all. This is all numerical, so that can all just be typed in. And it figures out to be about 14,526. Yep, 14.526. Again, that's in thousands, so move your decimal 3 places. So 14,526 units.